Hello all. In this presentation, I'm going to explain about structural engineering under module 1, that is Introduction to Civil Engineering. So we have studied many different fields in civil engineering, the basics of introduction of all the different disciplines. So here is one of the discipline, one of the category, that is structural engineering. Okay, structural engineering is an study like how to design the structures and non-structural elements which bears the load, and also it seeks to determine the sustainability and also the stability of all the parts of the building. For example, the column, beams, the wall, foundation, roof, etc. So these are all the parts of the building and how they will carry the load, and ultimately how the load is going to transfer to the soil through the foundation. Okay, so this is all about the structural engineering, that basically we are going to deal with the calculation of the loads in all the structures, not only in the building or a houses. So it is depend on the structures, parts of the structures. It depends on all the structures. Okay, so it is a field that deals with structural design, structural integrity, and also the strength of the building or a structure. So structural engineering is a specialty in the civil engineering which ensures that structures are safe, stable, and do not collapse under the applied loads. So whatever the loads. So now we'll see for individual structure, or we will take a building, right? One example, a building or any house. So what are the types of the loads it can take up? Okay, so the types of the loads acting on the structure for a buildings and other structures can be broadly classified as vertical loads, horizontal loads, and longitudinal loads. Here the vertical loads will play a major role, and the vertical loads consist of dead load, live load, and the impact load. So here are the few list are there, that is types of the loads acting on a structure are dead loads, imposed loads, wind loads, snow loads, earthquake loads, and a special loads. So first of all, like what is dead load? Like dead loads are the permanent loads or a stationary loads, like which will be transferred to the structure throughout the lifespan. Okay, maybe one structure is going to construct after the construction, may it will be there for more than 80 years or 100 years. Till that there will be a dead loads. So that is, for example, the dead loads is primarily due to the self-fate of their own members. Members means the permanent partition walls will be there, fixed permanent equipments. Some of the equipment will be fixed throughout the life of the building, and weight of the different materials, and it majorly consists of a weight of a roofs. Okay, roof weight and the beam weight, wall weight, and a pillar. The pillar is commonly known as the column, etc. These are all the permanent parts of the building. Okay, so here a structural engineer must know about the core knowledge in all these things. Physics, mathematics knowledge should be there for calculations. A strong supportive network, software skills should be there. So what is live loads? Live load is also called as a imposed loads. Okay, so the vertical load that is considered in a design of a structure is imposed loads or live loads. But live load either movable or the moving loads without any acceleration or a impact. And these loads are assumed to be produced by intended use or occupancy of the building, including the weights of movable partitions or a furniture. For example, in house, like we'll be keeping many furnitures, utensils. So there's that are all the live loads. May it be we are keeping for some time and we are taking out. So that loads are called as live loads. Maybe we are all the people will be roaming, will be sitting, or they are living throughout the building life, but they are, that load will be live loads. Sometime the loads will be there, sometime it is coming out of that part. So that loads are called as live loads. Next, wind load. Here, like wind loads are primarily considering as a horizontal load, like because of the causing the load causing by the movement of the air or relative to the earth. But wind load is required to be considered in structural design, especially when the building exceeds two times the dimensions of the transverse load to be exposed in a wind surface. So that also should be calculated. And snow loads, here snow loads will be constitute of a vertical load, but it will be we are considering only in the place of where the snow falls. Next is earthquake load. I think earthquake forces constitute to both vertical and horizontal. It is combined, but the total vibration will be caused by earthquake may be resolved into three different mutually perpendicular directions, that is usually taken as vertical or horizontal. It is going to resolve any load, any direction, it is going to resolve for both the direction, uh, vertically resolving and also the horizontal directions. So here I just came up with an example, like in one of the building in India, that Antilia. It is designed to survive an earthquake of magnitude 8. So it designed in such a way. I think it's of 27 floors and also 173 meters tall, over 37,000 square meters, and with all the amenities such as 3 helipads, air traffic control, 168 car garage, a ballroom, 9 high speed elevators, and also a 50-seat theater, terrace gardening. Okay, these are all the different amenities and the facilities it contains. So this home is designed to survive of earthquake of magnitude 8. And also here the snow room that spits out the snowflakes from the walls, and also the skies scraper machine is one of the world's largest and most elaborated private homes. So these are the facilities are there in this. So I just came up with this example. And also the design part and the load calculation, it should be done before the construction started. I think it's must and should. Like after the construction, like we can't change any design or uh, any the construction part, because once the structure is constructed, may it will long last for maybe for the 80 or 100 years. So definitely it should be stable in condition, should be comfortable for living, with a good quality materials we need to construct. So in that manner, like, so the building or any structure, house, anything, it should be construct in such a way that it should withstand all the type of the loads, that all the type of the loads we have seen, right? So all the type of the loads it should withstand. That is the main aim of the structural engineers. They have to be having they have to know the calculation part and also the core knowledge about the calculation of all the loads. So this is about the structural engineering. So and what are the responsibilities of structural engineers. Thank you.